All right, now this one goes all the way to 11, and I don't have 11 spaces here to work with. So what we decided in the other classes would go by twos. Is that all right? Or go by each one is two. Is that all right? Okay, so yeah, because sometimes if it goes up too big, you don't want to take up your whole paper on it, and I just don't have enough room here. Yeah, and I can't, and I know that I can change the size of these boxes and get more boxes in there, but I just don't want to figure it out right now. Because I made it this size, but I don't know how to make it. I just can't remember. Anyway, let's do this. 11, negative 1. So let's go by twos. 2, 4, 6, 8, 10, 11. And negative 1 would be about right there. Agreed? So that's 11, negative 1. And then we have negative 3, negative 11. So negative 2, negative 3, and then negative 11, right? Will I even have enough room? 2, 4, 6, 8, 10, 11, right there. Yep, so it works. So it's negative 3, negative 11. All right, let's connect the 2 points to get our line. All right, we're good to go now. Now, let's change colors. We'll stick with the blue. It's been nice to us, hasn't it? Negative 1, 1. So negative 1, 1, right there. And we want to make perpendicular, right? So probably, I don't know, what do you think? My guess is it's probably going to be there. It looks like so far they've made it kind of easy for us, haven't they? And put it right on the number. Now, I got to say, that I can't promise you that every single time it's going to hit right on an integer number. It could hit at a fraction somewhere. All right, so, be careful. I mean, I could just look at that and say, oh, it's 2, negative 3, distance formula, boom, done. And I might be right, okay? And I probably am right. But I just want to make sure that you know how to find this point if you can't just tell by looking at the graph. Does that make sense? Okay. So I'm going to make that x and y right there. All right, let's go through it. So what's the first thing we need to do? We need to find the equations of both lines. So let's do the red line first. So we'll do it up here. Y equals mx plus b. So here it is. You can find the slope. If you want, you could just count. Well, let's not count because they're halfway. Let's just put it into the formula. We'll do it real quick. Subtract the y's, so it's negative 1. Let's do it in our head. Negative 1, what? Plus 11? What's negative 1 plus 11? 10, isn't it? Okay, that's what I thought. Okay, and then do the x's. 11 minus negative 3, or 11 plus 3, which is 14. So what does that reduce to? 5/7. Okay, so that's my slope. Now, this is where, see, it's 5/7. Now, usually we got the slopes to come out to nice even numbers, didn't we? But it's going to be a little ugly, I'll warn you. So let's put some numbers in. You can pick either this one or this one. Let's pick this one right here. All right, it doesn't matter, right? Put in the y, so it's negative 1 equals m, which is 5/7, x, which is 11, plus b. So it's negative 1 equals, what's that? 55/7. Let's get rid of the 55/7. We do that by subtracting. But let's change this negative 1 to a negative 7/7 because I got a denominator of 7. Subtract 55. Make sure you're double checking my arithmetic here. So that's negative 62/7, and that's the slope. Or, I'm sorry, that's the y-intercept. All right, so we got our slope, we got our y-intercept. Let's put it all together. Y equals 5/7 x, and then our b is negative 62/7. And put it in a box. We'll hang on to it for a few minutes. That wasn't horrible, was it? No. Let's do the equation of the blue line now. Now, we're going to use the red line. We found the slope of the red one is 5/7. So what's the slope of the blue one going to be? Negative 7/5, right? It's the negative reciprocal. And we know a point on the blue line, and it's negative 1, 1. So now we're going to find the equation of the blue line. I'm going to write y equals mx plus b again. And let's put some stuff in here. Put the y in there, which is a 1, equals the slope, which is negative 7/5, times x, which is negative 1, put it over 1, plus b. So it's 1 equals, that's positive 7/5 plus b. Subtract a 7/5. Well, let's turn this into what? 5/5, right? So we subtract a 7/5. 5/5 minus 7/5 is negative 2/5. And that's what b is. So we have our slope right here. We have our y-intercept. Let's put it all together nice and neat. Y equals negative 7/5 x. Our slope, negative 2/5. And there's our other one. Okay? So really, all we did was just found the equation of both of those lines. That's stuff you did in Algebra 1, isn't it? But now what do we do with these two? Look, this is equal to y, this is equal to y. So set them equal to each other. Now, it's not so easy to do elimination on this one, is it? I mean, I guess technically you could, but I think the easiest way, personally, is just to set them equal to each other. I'll tell you what, since I'm just doing some math right here, let's just get rid of my grid marks, and then we'll put them back a little bit later. All right, so let's set these equal to each other. This is where it gets a little bit ugly. I mean, it's not hard. It's basic fractions, finding common denominator stuff. But for a lot of people, this really bothers them. All right. Oops, I forgot the x on the right there. All right, there you go. And now you got to solve for x. Let's just do it. I'll just show you how I would do this. I would add a 7/5 to both sides. Okay, so what do you get? You get 5/7 x plus what? 7/5 x. Agreed? Yeah. So we got rid of that, didn't we? Let's get rid of the 62 over 7, put it on the other side. So equals, now this is a minus 2/5. If I add this, I get what? Plus 62/7. Let's add like terms, well, yeah, let's add these things together. But we got a common denominator, 7 and 5, that's easy. What is it? 35. Now what do we do to 7 to get to 35? 7 times 5, so 5 times 5, that'll give me 25. Agreed? We'll put an x. And then 5 times 7, so 7 times 7 is 49x. Actually, I shouldn't have put the x's there. I should just put the x's on the end. Is that all right? I'll just get rid of that. And then just put the x right here. You okay with that? All right, so what do we get here? That gives us 74, is that right? 74. Did I do my math right? Anybody talking to me now? You mad at me? All right. All right, let's do this over here. Again, common denominator, right? I mean, this is stuff you did like in 5th grade, isn't it? Yeah. This kind of stuff, yeah. So common denominator, so this times what? 7, so that times 7, which is negative, how about 14? This times 7. 5 times 7, negative 2 times 7. Okay, it's just negative 14. Now this one, you're right. 7 times 5, somebody do that for me. What's 62 times 5? I should be able to do that. Times 5, that's a 10, that's a 310, right? Yeah. Okay. 310 minus 14 is what? 296, is that right? Yeah. Okay, 296 over 35. It's pretty ugly, isn't it? Yeah. Okay. But watch. It's like magic right here, okay? They rigged this, okay, but it's kind of nice. How do I get rid of 35 or 75 over 35? Or 74 over 35. Yeah, multiplied by the reciprocal. Remember that? Okay? Yes? You remember that, don't you? And then you do the same thing over here. 35 over 74. Watch what happens. Those cancel, those cancel. I got x by itself. Now, this is magic. Watch. Bang, bang. Does 74 go into 296? You got a calculator? It does. It goes exactly 4 times. Wasn't that nice of them? Okay? It's just all, look, it's 5th grade right there, isn't it? Not really. Well, kind of. I mean, the fractions, look, the algebra part wasn't the hard part. That's not the parts that you don't understand. It's just doing all the fractions and all the little tedious little things, okay? Well, it's because you didn't learn fractions in the first place. That's why you hate them. All right, so we got x equals 4. Now what do we have to solve for? Got to solve for y. I could use this red one or the blue one. It doesn't make any difference. Which one would you rather use? The blue? Okay, let's use the blue. So y equals negative 7/5 times x. What was x? It's just a 4. And then minus 2/5, right? let's simplify this. What's this going to be? Negative 28 fifths, right? Minus 2 fifths. Ah, look how nice. I see it already, don't you? This is negative 30 fifths, which is negative 6. Ah, so y is negative 6. So why did we go through all that mess? To find this point right here. This lousy point. Make us go through all that stuff.
It looks like it's exactly in the middle of those
two. It looks like it, but you don't know that, right? You don't know it's always going to do that. So what's our point? It's 4, negative 6. All right? And we're almost done. All right? The next part's the easy part. What's that? Just finding the distance. I'll tell you what. Let's change the color just so all our steps are different color coded. Let's go purple. All right, so distance equals big square root. Now look, they could have had these numbers come out to crazy fractions. You got to put crazy fractions in here. I mean, that could have very well happened, right? But they were nice to you, kind of, right? And they made them come out. I mean, again, they rigged these things so it came out real nice for you. So let's subtract the x's. Yeah, could you I mean, think about how bad it is to do the problem. Think about what it would be like to come up with a problem to make sure your x and y came out nice and even. I mean, you know, that takes some thought. So anyway, I'm not trying to make you feel sorry for them or anything, but here we go. Subtract the x's. So what do we get? 4 minus negative 1, 4 plus 1, which is what? 5, right? And then do the y's. Negative 6 minus 1, which is negative 7, right? Or you can just say 7. It doesn't matter. So what is that? 25 and 49. Did I do my math right? Double check. Did I do that? 4 minus negative 1 is 5, yep. Negative 6 minus 1, yep. Negative 7. So what's that? That's 60. 74, is that right? Square root of 74. Does that look familiar?
Yeah.
Yep, that's it right there. How about that? Wasn't that fun? That's the thing, man. You make one mistake, you mess up one time in here, and you're done for, aren't you? Now look. It's the square root of 74, and that's it. But look at this point right here, 4, negative 6. Let's see if it really was 4, negative 6. Yep. Remember, we went by 2's, right? 2, 4, yep. 2, 4, 6. Yep, sure enough. Right where it's supposed to be, isn't it? And that's kind of fun, isn't it? To see that you did all that math, and it ends up right where you thought it was going to be. Isn't that cool?
Yeah.
Sure.
You guys aren't sharing my enthusiasm. What's wrong? Okay. But it's... Being paid has nothing to do with your enthusiasm, believe me. You get paid for a lot of stuff. Oh, is that what it is? I just want to share. I want you to share in my enthusiasm. All right. I'm going to give you, listen. I'm going to let you, if there was a couple here that we didn't do, let's listen, please. Shh. If there's a couple on here you couldn't do, I'm going to let you hang on to it and turn it in on Monday. I do have a worksheet for you. And I don't think I made enough. There's only 4 problems on the worksheet, so it's not that much. It's the same kind of problems. All right. My initial plan, listen to me. My initial plan was to do the second half of this lesson today and finish this lesson. Doesn't look like that's going to happen. All right, so we'll finish it on Monday, because what we're going to do is this. I know you're excited about this, but watch. We're going to do 2 parallel lines, and we're going to find, let me, if I can grab that, there we go. Watch, we're going to have 2 parallel lines like this, and we're going to actually find the distance between those 2 parallel lines. Isn't that exciting? All right. Yeah, so we're going to find that distance right there, knowing what these parallel lines are. All right. So that's what we're going to do on Monday. That's the second half of this lesson. Yeah, it's pretty much the same thing. These slopes are the same, but this is still perpendicular to this.
Perpendicular.
Well, just like we did before, we're going to find that point, we're going to find this point, and then we're going to use the distance formula to find the distance between them. Okay? It's a little bit of a extra step. It's pretty much the same thing, though. But that's what we'll do on Monday. And let me stop this and let me get a worksheet for you.